Hi, I'm Adam Crespi, and welcome to the Autodesk Maya Certification Exam Preparation. Just so you know a little bit about me, I'm an Autodesk Certified Instructor, and I have been since 2004. I've been a Certification Evaluator since 2010, and I'm a Senior CG Instructor at the Art Institute of Seattle. I've got over 20 years experience in design visualization, animation, and games. And I started out, believe it or not, in 3D Studio Release 1 for DOS and Maya 1 for Erix. In this AU virtual session, you'll explore the objectives for the Autodesk Maya certification exams. The certification topics covered in this session include modeling, rigging, animation, cameras, materials and shading, rendering, data management and interoperability, dynamics and simulation, effects, lighting, scene assembly and pipeline integration, scripting, and UI and object management. At the end of this class, you'll be able to use my tips and tricks to prepare for the exam. Prepare for the exam by reviewing the certification roadmap and map the learning objectives to the study materials. Here's a brief overview of the exam format. It's composed of three different kinds of items. Simulation items, where you're asked to perform a particular task in the application and either return a value or have a visible change. Multiple choice questions, where you'll have to choose the right answer from a selection. And matching and hotspot or identification, where you'll have to click on or identify a particular piece of the UI, for example. You may also have to match different objects or attributes with their descriptions. So let's get started with the Autodesk Maya certification exam preparation. In this section on UI and scene management, we'll explore the basics of navigation in the Maya user interface, look at how to switch display modes, and select objects. We'll also look at how to organize objects and where their pivots are. I'll start by looking at the UI. The Maya UI is very logical and organized. Up on the top, we have the main toolbar and the status line right below it, with fields like the menu line input and render setup buttons. Below that are the shelves, and these provide ways to get to the different modules such as surfaces, polygons, and rendering. On the left is the toolbox, and that has common commands as well as last used tools. On the right side we have the channel box and the attribute editor, accessible by pressing Ctrl-A or using the tabs on the side. Finally, on the bottom we have our timeline, where we have the time in the scene and also the ability to cut and paste frames, for example. Below that is our status line and help line. I'll start out by selecting objects. When I select one object, its wireframe turns green. Holding Shift, for example, and selecting another object shows the last selected in green and any other selected objects in a white wireframe. We can switch our display modes by using our hotkeys: 4 for wireframe, 5 for shaded, 6 for showing textures, and 7 for displaying scene lights. We can also switch how we're displaying our objects. Right now, clicking on the Renderer menu in the Viewport label shows me that I'm using the default quality rendering. I can switch over to High Quality or Viewport 2.0 for a different look. I'll choose Viewport 2.0, and there's the normal map showing on my arches, for example, of the board form concrete. I'll go into the Viewport 2.0 configuration dialog and further modify what I'm seeing. We can turn on anti-aliasing in the view. For example, multi-sampling anti-aliasing makes the flutes on the lampposts look clearer. We can also turn on screen space occlusion. And now we have ambient occlusion grounding our objects in the scene. I'll press 7 to make sure I'm showing the scene lights. We can additionally turn on, in lighting, shadows if we'd like. We have a number of ways to select and organize our objects in the scene. We can start with the outliner, choosing Window and Outliner. This provides a list of all the objects in the scene. Right-clicking the outliner shows a sort order, and right now it's set to the scene hierarchy. If we choose alphabetical within type, the objects are organized by their names alphabetically. We can use the hotbox also to navigate around. Pressing and holding the spacebar pulls up the hotbox, and as you can see here, I've slimmed mine down using the hotbox controls. I've clicked on Hotbox Controls, Show Polygons, and Polygons Only, so I just have the menu set for the polygon modeling tools. Pressing F2 for animation, for example, and then pressing and holding the spacebar shows me just the menu for animation. This way we can keep the tools at hand that we need and reduce visual clutter in the UI. I'll switch back to a perspective view by pressing and holding the spacebar and clicking on the Maya button and choosing Perspective View. We can see objects' pivots when we select them and choose a tool that shows that pivot, or press D for Enter Edit Mode. I'll select one of my arches and press W for Move, for example. The pivot for the arch is over on the left side. Keep in mind that when primitives are created, their center is in the center until it's moved. When I rotate this object, for example, around its pivot by pressing E for rotation and clicking and dragging on the green Y axis, we can see that that arch rotates around its pivot. It's important to know where objects' pivots are, because that lets us not only snap things together if we move the pivot or snap to vertices, for example, but rotate them precisely where we want them to be. Once we've got a firm handle on how our scenes are organized, and how things are named and where their pivots sit, and also how to change our display for optimal working, we can dive into things like modeling, animation, and lighting. Modeling is a large subject in Maya, and we have many different tools available to help us get what we need modeled efficiently. We have polygon tools, NURBS, and surfaces, and we can toggle freely between them. Additionally, we can show our polygons smoothed in the view if we'd like, and we have a lot of detailed tools for putting in what we need. This bridge, for example, has been modeled from all kinds of different primitives. Cylinders started out to make some of the brackets. The arches actually started out as boxes that were then bent. The lamppost may have started as cylinders, and the sides were extruded in to make the flutes. We can see all kinds of different base models here that have been thoroughly modified to produce this bridge we see. I'll start out in a new scene, clicking on the New button and not saving this particular bridge. When we begin a clean scene in Maya, our units are in centimeters, and to change that we can choose Window, Settings Preferences, Preferences. And in the Settings, we set our linear units to centimeters, or whatever we'd like. I'll start out by modeling a cube, holding Shift and right-clicking, and pulling up the marking menu for polygon creation. I'll pick Polycube and click and drag in the view while holding Shift to produce a cube, or free click and drag to produce a box. I'll press 5 to shade this and zoom around. I'm using Alt and my mouse wheel to pan, Alt and the left mouse to tumble, and Alt and the right mouse to dolly back and forth. To duplicate an object, select it and press Ctrl D or choose Edit and Duplicate. I'll press W to move and pull this object away from the original. Duplicate with Transform, or Shift D, duplicates the object and repeats the last transform, which can be move, rotate, or scale, or a combination of any one of those in any direction. Choosing Edit and Duplicate Special and picking the dialog next to it pulls up the Duplicate Special options, which let us do arrays if we need, and we have choices over duplicating the input graph and instancing the leaf nodes. When we're modeling objects, we have a lot of different tools available, especially in the polygon modeling tools. I'll press F3 to switch to polygons, and Shift and right click, and I have a marking menu with different tools on it, such as Insert Edge Loop and Quadrangulate and Separate. Pressing F11, for example, to switch to face, and selecting a face, and notice the red pre-selection highlight lets me select a face. And once I've got a component such as a face selected, I can hold Shift and right click and extrude. I'll pull this face out, scale it in on the X, scale it on the Y, and move it up on the Y. I can even rotate as part of that extrusion. This is showing here in the channel box as Polyextrude Face 1, and it shows that I've translated locally, for example, by -2.453, and there's my local Z translate at 3.85. Here's a local X rotate. Repeating an extrusion on another polygon by pressing G to repeat last, and switching over to the world coordinate system produces different results in the channel box. I can see my translate y on the extrude up at the top is now 5.221, for example. It's important to keep in mind if you're using the local or world coordinates when extruding. We can also get to this in the Attribute Editor, clicking on the Attribute Editor tab, and we need to make sure we're operating in the right particular modifier. This object, for example, has polyextrude face 2 and polyextrude face 1. To get information about the scene, such as the polygon count or number of tries, for example, choose Display, Heads-Up Display, and Poly Count. We can see in here, when I pan to refresh the view and select an object, that this particular extruded box, we'll call it, has 28 tries. The whole scene has 52. This box has 14 faces and the whole scene has 26. We use this particularly in games, where polygon count and keeping it low is essential to have high frame rates. When we're modeling, we can also choose to see our objects in different views. I'll select my extruded box. Pressing 2 shows me a smooth preview with a cage. Pressing 3 shows me just the smooth object, and pressing 1 takes me back to the original. This lets me see it when it's subdivided. We can access this also by pressing 2 and switching over to the Shape node. In here are smooth mesh controls. I have control in here over the division levels and local control over the preview and how it's shown. In addition to polygons, we can work in NURBS. I'll go over to the Surfaces or Curves section and make a NURBS object such as a sphere. I'll click on the sphere on the shelf and click and drag out a sphere. Right-clicking on a NURBS object shows it's composed of different pieces than the polygon objects. NURBS are made of isoparms, control vertices, surface patches, and surface points. They have surface UVs and hulls. We can contrast this to polygon objects that have vertices, vertex faces, faces, UVs, and edges. For a NURBS surface, right-clicking and choosing Control Vertex, for example, shows the control vertices outside the object. Pulling on a CV, pressing W for Move, shows a smooth deformation in the mesh. And we can see that this vertex has an influence on its adjacent hull. Selecting a polygon object and right-clicking and choosing Vertex, for example, and pulling on a vertex, produces a rigid deformation in the object. As you can see, I'm also introducing some odd smoothing across this, because I'm deforming this polygon. It's important to understand your polygon modeling tools and the versatility within them. It's also important to understand your NURBS modeling tools and the different components of each object, how to get to them, what they do, and how they affect their shape. We also need to know how to display this object and see its statistics, and to change what we're seeing in smoothness. Finally, keep in mind that Maya does keep a history, and being able to navigate through the Attribute Editor tabs and find the right information for whatever it is crucial. With a good idea of modeling, we can dive into other things like lighting, now that the models are in place to let the light shade on them properly. In Maya, cameras are versatile storytelling objects. I've got a camera in this bridge scene, for example, and we can see that the camera has been animated to come up over the railing and reveal the roadway, and maybe a car coming towards us, for example, in an establishing shot. We can select a camera by clicking on the camera icon or choosing View and Select Camera. With the camera selected, we can see different attributes are available. We've got our basic transforms and also camera-specific pieces like focal length, lens squeeze ratio, and focus distance. Pressing Ctrl A to go to the Attribute Editor shows us even more attributes are available. The focal length for a camera is in millimeters and corresponds to an angle of view, with a lower focal length increasing the angle of view. The near and far clip plane determine how far out that camera sees, and also how close before objects are clipped off. The film back defines how this film gate fits, and how the aperture relates back to our film when we're printing. As a side note, this camera is connected to a physical sky as part of the daylight system, and also a photographic exposure for tone mapping using the Mental Ray rendering engine. We can create a camera by choosing Create, Cameras, and Camera. We can think of a camera as a handheld camera. It exists with one transform, right here at the rostrum. The focal length defaults to 35 millimeters, and the near and far clip plane are 0.1 and 10,000. Switching this over from a camera to a camera and aim, for example, produces an aim node. We can move the aim node, and the camera rotates to follow. Changing the camera over to a camera aim and up adds an up node, ensuring that this camera will always face up at the up node and avoid gimbal lock or flipping. Once we've decided on the type of camera we're using, the focal length, and we've positioned the camera in our shot for the best composition, we can also turn off and on different viewport aids for the camera. I'll turn on the resolution gate, and this shows, based on my 1280 by 720 rendering, what will be in the rendered frame and what will be outside. There's a gate mask in gray outside that res gate. Action Safe and Title Safe, for example, show us where we should keep our work inside to be properly viewable on screen. Finally, we have camera controls available under View, and there are camera tools such as Tumble, Track, Dolly, Zoom, and 2D Pan and Zoom. A camera is a versatile storytelling tool, and we should use our cameras in conjunction with our res gates to compose our images. We should think about the focal length and the angle of view, and how deep we want our scenes to look, or how shallow and how flat. Knowing how to place the camera and compose the scene is a vital piece of cinematography, and getting the story across that you want your audience to see. Good lighting can make or break a scene, and bad lighting can make even a great model look not so good. This bridge scene is lit by a directional light. It's actually part of the daylight system, so there's a physical sun actually controlling how the light looks. We can recognize the directional light because of the parallel arrows. There are 6 basic light types in Maya: ambient, directional, point, spot, area, and volume. To create a light, either click on the light icon on the rendering shelf or choose Create, Lights, and the type of light you'd like. I'll make a point light, for example, in my scene. Press W to move it up, and press 7 to show it in the view. Point lights are spheres of light. They radiate out equally in all directions. Creating a spotlight gives us a cone of light. I'll make a spot, pull it up, and press E to rotate. I can also press T for target and pull the target of this light down in to aim it in my scene. We can see this light aiming down at my objects. I pressed and held W for the marking menu for the Move tool, and left click and held, and switch this light over so it's moving on its local axis. As I pull this light out, we can see the light affecting the scene in a cone. I'll switch over to Viewport 2.0 so I can see this better. I'll press Ctrl A, and in the attributes we can see some things that are common to all lights and some that are unique to a spot, for example. All lights have a color and intensity. Intensity for brightness and color for the light color being emitted. Here's a pink or red light, for example. The spotlight has a cone, penumbra, and drop-off. Cone defining the size of the light. Penumbra being the softness of the diffuse edge expressed in degrees. And drop-off from the center of the light to the edge is a fall-off in intensity, so we can soften out that light or harden up that edge. In a light, decay then defines a relationship, and there are 3 basic decay modes besides no decay: linear, quadratic, and cubic, with linear being an inverse fall-off, twice the distance and half the light. Quadratic and cubic are inverse squared and inverse cubed, respectively. Once I change over to linear decay, my scene goes dark until I bring up the intensity considerably. Directional lights, as contrary to spots, have parallel rays. I've created a directional light, and I'll pull it up in my scene, rotate it over, and aim it down. As a side note, to make this light bigger, increase the locator scale in the object display. Scaling lights actually has different effects on them. My directional light has parallel rays, and we can access those rays and get them out of parallel if we need. I'll go into shadows. Most of the lights we have will cast shadows, and those shadows can be either depth mapped, approximating the fuzziness of a natural shadow, or ray traced. In this case, ray traced is on. Ray traced shadows are hard-edged until we soften them out. For this directional light, for example, I'll go in the ray trace shadow attributes and increase the light angle to soften out those shadows. I'll switch over to my high quality rendering and turn on lighting and shadows. And there's my ray trace shadows, my directional light. I've also got lapping shadows from my spotlight, which we can see as I pull these back and forth. Different display modes display different kinds of lighting and resolutions. An area light gives us, as the name suggests, a large square of light. I'll rotate this over in my scene, and where I can see that vector is where the area light is aiming. Scaling an area light increases the size and brightness. I'll rotate this light down and pull it up so we can see it more. I'll take out my directional light and take out my spot as well. My scene is lit by my area light, and the large shadows in here are relative to the amount of rays I'm casting. Keep in mind with area lights that the bigger they get, the brighter they get. So when I render this frame, I may get a very, very bright spot from that area light. There are many schools of thought in lighting. Three-point lighting is the idea of a key light, a fill light, and a rim light. I'll press 6 to go back to a shaded view and create some lights in my scene. Here's one spotlight for my key, and I'll pull it up, press T for target, move the target over, and get the light up to aim at that sphere. I'll duplicate this light by pressing Ctrl D. And by the way, if you have the target on and you duplicate the light, the duplicate slides around the target. Typically our key light is the full intensity, and the fill light would be half of the key. I'll back off the intensity, so it's a white light emitting less intense light. In a render, I can see that I've got crossing light and lapping shadows. For both lights, I'll increase their cone angle, selecting them and going to the channel box. I've selected 40 and cone angle, and I'll click and drag with the mouse wheel in the view to make those lights a bigger cone and soften them out. I'll also increase their penumbra, scrubbing out to maybe about 7 degrees or so, give or take, and I'll put a drop-off in. Now that light is definitely different. We can see it's nice and soft, and those objects have some directionality in the lighting. Finally, a rim light will backlight the objects and pick them off the background. When objects have a shiny material on them, we should be able to clearly spot the specular highlight. I'll put a blend shader on this sphere, and I can see it is now shiny. The specular highlight is here in white. This may be quite muddled depending on the lighting in the scene, so make sure that you can clearly identify how that light is shining on the object and where it's coming from. Lighting in a scene can provide the drama to really make a scene sit well and make good models look fantastic. Understanding how to place lights, different conventions with lights, and how to manipulate and adjust them to get a certain mood across is crucial to a cinematographer in Maya. Materials and shading go hand in hand with lighting in bringing a scene to life. We should be able to look at an object and have a pretty good idea of its material, and looking at the attribute editor to see what the shader is will tell us exactly what's going on. This sphere has a blend material assigned. It's a blend shader defining how that light reacts with that object. The color, or diffuse color here, is our 50% gray. To assign a material, select an object, right-click, and choose Assign New Material. In the Assign Material dialog, we have all of our different materials listed, with all of our standard Maya ones up at the top, and our mental rays, noted with an MI here, down underneath. I'll assign, for example, a Phong shader to this cube, and I'll make that diffuse color blue by clicking on it and choosing a blue. In a material, we can adjust things like shininess, in this case shown by cosine pallor and specular color. In our blend material, we can adjust the shine by eccentricity and specular roll-off. Roll-off would make a material shinier, and a lower eccentricity will concentrate that highlight. We can adjust the specular color of a material as well, putting in maybe a brighter white to make it look shinier, for example. You should be able to assign materials either through the right-click menu, the Node Editor, or the Hypershade, and to comfortably navigate around each one. I'll choose Window, Rendering Editors, and Hypershade to pull up my Hypershade. The Hypershade displays our materials in a node-based graph. I'll right-click on the blend to graph it, for example, and there's that material, showing just that basic material. Textures go hand in hand with materials, as they provide attributes for a material beyond a simple solid color or value. We can see, for example, on this arch, that it's using a mental ray material called Concrete Arches Passes, and it's a primarily yellow color. There's a texture down here in the bump and in the standard bump slot. Looking at this object in the texture editor by choosing Edit UVs and UV Texture Editor, we can see where those arches are laid out. I'll click on the Toggle Shaded UVs and we can see that arch cleanly laid out to fill in that space. And there's other arches that actually sit in there with it for a varied look in the concrete. In the UV Texture Editor, we can select and move shells and UVs, selecting an arch, for example, and pulling it to move where that texture sits in the object. Remember, with materials, we can put a lot of subtlety into them, but it takes good lighting to show it. It takes good materials to show good lighting, and both of them need a good model, one that's got the contour and enough polygons to be able to shine and show correctly. Understanding how your materials work, what their shaders are, what their properties are within those shaders, and how to switch between or assign them to objects is important. And we should be able to look in a rendered image and cleanly identify components of a material. Rigging is the process of putting a skeleton inside a character or other model, so that it can be animated and either smoothly deform the mesh or create a mechanical linkage, for example. To create a skeleton, press F2 for animation and choose Skeleton and Joint tool. I'll click to make one joint, click to end it and make the next, and so on. This is an example of a leg with the start of a foot on it, and it bends backwards at the moment like a bird. Joints exist in a parent-child relationship, where each joint is the parent of the one below it. Until we constrain them, joints are scalable, that is, the rig can be stretchy. When we pull these joints around, the child moving rotates the parent. Picking the next child down, for example, rotates the other parent, and there's my leg. IKs, or inverse kinematics, allow us to pick the end of a joint chain, or something close to it, and move it and affect the rest of the leg, for example. I'll pick the first joint in the chain, and choose Skeleton, IK Handle tool. I'll pick the root node and where I want the IK to go down to. We can now see that there's an IK goal, and pulling it up bends that leg up. We can see that after the IK it is FK, forward kinematic, in that I would have to pick those joints and move them or rotate them to position where I want for an animation. This is an IK handle using the SC solver. We can change the solver here by going into the solver attributes and changing away from, let's say, single chain to rotate plane or human IK. Within these solvers, we can also look at the size of the goal, stickiness and snapping, and what is the end joint in the chain. We should be able to cleanly identify bones and what the parent of each bone is. When we select bones, we have options here for radius, draw style, degrees of freedom and stiffness, and is there a label on that joint for ease of recognition and animation. Rigging can be very technical, and we can often see scripting plugged into it, so that beyond simply placing the bones in a rig, the functionality is readily apparent and easy to use for an animator. We should keep this in mind when we're making a rig, but understanding the relationship of parents and children and how IKs affect the movement of a joint is crucial to starting out in rigging. Animation is where we bring things to life in Maya. Without animation, we're making pieces that are exactly static and can be a little dead or stiff. In this scene, I've animated the camera to rise up over the bridge in my establishing shot. I've keyed move and rotation and incidentally scale invisibility by pressing S. When I select the camera, we can see here in the channel box that in the Camera 1 node, all of those properties have a red field on them, meaning that those are keyed. And down in the timeline I have two ticks visible, at frame 1 and frame 96. The neat part is if you can think about it, you can animate it. We can animate anything we'd like in Maya, including focal length, object position, material color, lights turning off and on. Really, anything you want to animate, you can animate. I'll change the focal length, for example, pressing Ctrl-A to go to the attribute editor. I'll start out here at frame 1 and put in a focal length of 35 millimeters. I'll right-click on the name focal length and choose Set Key. Maya works by default in Set Key, meaning that we put at the frame the motion in we want and then add the keyframe. Opposite of this is Auto Key, where it creates keyframes automatically when we go to a new frame and change that property. I'll scrub out to frame 120 and change this focal length to 28 to make the scene look deeper. Right-click on focal length and set another key. Now when I play this animation, we can see that focal length change in addition to that move. We can also see in here there's a bit of a zig at the end, and we need to adjust the animation. I'll choose Window, Animation Editors, Graph Editor. In this case in the Graph Editor I have the Camera 1 shape node selected, and there's that animation for that focal length change. It's expressed as units over time, where in this case the units on the left side are millimeters of focal length. When I pick, for example, Camera 1, or select, let's say, Translate, Rotate, and Scale, the other keyed properties, and Frame All, we can see the curves for those attributes that have been animated. They're not giant changes, and we can see that the units on the left are very big versus the amount of change shown on frames in the bottom. This camera moves up and rotates into place, and I've affected these curves by selecting those keys, for example, down here, and with that key we can see handles on it. What those mean is that that key influences the tween frames in a certain way, in this case using flat tangents or a slow in, slow out. By selecting keys and changing their tangent type, tangent weighting, and if the tangents are locked or unlocked, we can really change around how the animation looks and make it snappier if we need. As an alternate to the Graph Editor, we can use the Dope Sheet, choosing Window, Animation Editors, and Dope Sheet. I'll frame all again, and the Dope Sheet behaves like a traditional Dope Sheet or X Sheet in 2D animation. What we can see in here, opening up the camera, is that the keys are shown as ticks on the timeline, and we don't see the handles for them. What the Dope Sheet allows us to do is grab a whole range of keys very easily and move them around. Motion paths and recognizing them is a crucial part of animation. We'll use motion paths for lots of things, driving cars, flying planes, and so forth. Anywhere we need to make some kind of path or Bezier path and attach an object to it for a smooth animation. I'll select this cube I've created and then hold Shift and pick the NURB circle I intend as the path, and choose Animate, Motion Paths, and Attach to Motion Path. What happens is that that motion path is generated automatically for 24 frames, as that's what I have visible down in the timeline. Scrubbing on the timeline shows me that box revolving around that circle over 24 frames. In a motion path, which is a new node created on both objects, we can work in a parametric length and put in an exact keying of when that box should be in what place on that path. We also have choices in here over which way is up in case that path twists, and how we maintain up without completely flipping around. Constraints occupy a place between rigging and animation. What constraints do is establish a relationship between two objects. For example, I'll pick one object, hold Shift and pick another, and choose Constrain and Orient. This is a rotation constraint, where picking the first object and rotating it rotates the second, as it's matching that rotation. It's different than a parenting, because a parenting uses the pivot of the parent to rotate the child. In this case, both objects are rotating around their own pivots. The cool part with constraints, I think, is that they can have multiple objects in them. When I make a third cube, for example, and establish a constraint between all three, we'll see a different matter of rotation. With an orient constraint applied to all three, clicking and dragging on the y-axis of the large cube doesn't produce any rotation. Clicking and dragging on the y-axis of the second cube does. And what we're seeing here is that the selection order affects the constraint. In this case, because I have a still object, the middle cube, and a rotating object, the first cube, the large cube has half the rotation because it's an even split. We can use this idea to weight our constraints if we need. We should be able to recognize the different constraints and know where their tabs are in the attribute editor so we can see which way is up or which way they're constrained, what constraint we're using, and how those objects are behaving. A lot of times what we'll see in a rig and for animation are custom attributes. I'll add a custom attribute onto this box by choosing in the attribute editor, Attributes, Add Attributes. We should be able to add on attributes as needed to make animation easier. In this case, I'll make a custom attribute called Zip. And I'll let this be a float number with a minimum of 0 and no maximum and a default of 0. I'll click OK. And now on this object in the extra attributes I have my custom attribute Zip. I can use the expression editor or another way of scripting or the connection editor to tie this attribute to something else. This way I can distill the control on this object to a place that's easier to get to for animation. Perhaps it controls multiple objects' rotations and makes it easier to bring a scene to life. Keep in mind then with animation, we have a terrific tool here for it, and there are many different ways to get to it. We should be able to comfortably view keys on the timeline and also look at their tangents and identify the tangent type easily. We should be familiar with the animation editors, the graph editor and dope sheet, and also be familiar with where keyframes are in the attribute editor and the channel box, what they mean, what object is keyed and what those values are and how to get to them. We should be able to put objects on motion paths and change those motion path values. We should do the same with constraints, adding them on or looking at a constraint and finding particular settings in how that constraint behaves. Animation in Maya is such fun because it's a terrific way to, well, add life to the scene, to make it animated, and to really add some pop and personality into our models. In Maya, rendering is always an artistic choice. There's always a way that the images look that we have control over, and so it's important to think of it that way. Even the rendering engine we choose can determine how our images or movies look, and so we really need to think through that choice and then the different parameters in the rendering engines. I'll start by clicking on the Render Settings, and in here in the Common tab I can set things like the format, the name, color management if I'm using, a frame range, and image size, both width and height, and there are presets and even a pixel aspect ratio for non-square pixels. Depending on the renderer I choose, I've got different other parameters available. Maya Software, for example, has another tab for Maya Software, and I can deal with anti-aliasing quality, ray tracing quality, and so on. This particular scene was crafted in Mental Ray, and so in Mental Ray I have control over things like quality, which handles again ray tracing and so forth, indirect lighting for bouncing lighting, and things like the daylight system and environment. Our passes here control composite passes, where we can put out different images that do different things in a compositing program such as Autodesk Composite, allowing us to reassemble that final image to our exact liking. Maya Hardware 2.0, for example, is the rendering equivalent of what we see in Viewport 2.0 and contains all the parameters to be able to render out what we see in the viewport. The Maya Hardware 2.0 tab, then, is a match for the Viewport 2.0 controls, so we can render out a sequence of what we're displaying. The big deal is that different rendering engines have different capabilities. We should know the common settings and where to get in and set things like resolution and frame rate. We should know how to manipulate common settings for any renderer, setting the image size, name, path if necessary, and format. The other tabs available in the rendering engine, then, concern things that are particular to that rendering engine, how it deals with quality and anti-aliasing, for example, or bounce light if it's capable. Remember, it's an artistic choice. And being able to set that up here in the rendering engine defines what we can make our images look like, and also what materials that we can use. Data management and interoperability plays a huge role in a suite workflow. As wonderful as Maya is, we're going to use it in conjunction with other packages. We might use Mudbox for digital sculpting and texturing. We might send things back and forth to folks using 3ds Max, for example. We might deal with mocap data that comes in and is cleaned up in Motion Builder. We can export in different formats out of Maya, and what we choose and how we do it depends on what we need. I've selected one of the main concrete pylons here in my bridge scene, and I'll choose File and Export Selection. We can export one object or everything in the scene if we need. In Export Selection, we have a choice of where it goes, in this case to my default project. We can also choose what file, and our non-native file types such as FBX, for example, or OBJ, or DWG or DXF have different properties with them. FBX, for example, is a versatile transfer format that includes things like meshes, UVs, bones, skin weights, and animation. OBJ includes models, smoothing groups, UVs, and materials. So we have a lot of different choices on how we do this and what we send it to. Under File as well are the Send To options, sending to 3ds Max and sending as a new scene, sending out to Softimage, for example, or Motion Builder. We can also send to Mudbox out for sculpting or texturing. These options offer a one-click round trip with a live connection to those different applications. In all of this, it's important to have a good naming convention and clean structure in our files, so that when we import and export, we get the best out of our suite's workflow, and our pieces that we're working on go back and forth seamlessly. Some of the greatest strengths in Maya are dynamics and simulations. When we start out in a scene, making a plane for example, it exists simply where we put it. It doesn't actually participate with any kind of a gravity. Only by making things either active or passive rigid bodies, for example, can they be part of a simulation. I've got a plane, and I'll increase my frames up here to maybe, let's say 400. I'll make a ball, and put it up over the plane, pressing 5 for a shaded view, W for move, and moving it up and over my plane. Now I'll make the ball an active rigid body. Then I'll pick the plane and make it a passive rigid body. And finally I'll get some gravity on. What I'm doing with all these pieces is to add a rigid body attribute on. This actually thinks of it in terms of mass, center of mass, position where it starts out, and even if it's affected by fields. We have a lot of different control in here, but the big deal is to really say that yes, there is some gravity on it, and I'll play this and see how it looks. And I have a dynamic simulation in action. The ball is going to fall down, roll off the plane, and roll off into space. Recognizing dynamic objects and how they're behaving is key in a dynamic simulation. This plane, for example, has a rigid body 2 solver, and it's not active, meaning it's a passive rigid body and doesn't fall with gravity. It's got controls for things like static and dynamic friction and bounciness, contributing different properties to the way that ball bounces on that surface. The ball, in contrast, is an active rigid body. At the moment, it doesn't collide with any particles, although we can make it so, and it has its own attributes here for things like mass, bounciness, damping, and so on. They're all controlled by time, and that's available as an attribute tab. Both objects are linked to this field I've created, a gravity field, and that gravity has standard Earth gravity at the moment aiming straight down. We can get to these in the Dynamics Relationship Editor if we need, to associate objects with fields if we'd like. The big deal with dynamics is it's going to simulate as close as possible, well, real physics, letting things fall or crash, even braking if needed, reacting with rigid and soft bodies for deforming objects such as footsteps in the snow. We can add a lot of realism to our scene using dynamics and simulations, and understanding where and how to get to them and how to change their attributes is key to making realistic behavior. Fields in Maya are special objects that affect the behaviors or animations of other objects such as particles. In this scene, I've got an inclined plane that's a passive rigid body, and a particle system that simply sprays out gray spheres. I'd like to have the spheres drop with some gravity and react with the plane. I've already selected the plane and put a geoconnector on by choosing Make Collide under Particles, and now I'm ready for a field here. I'll select my particles and choose Fields and Gravity. The gravity we can see creates as a small down arrow right here at 0, 0 in my scene. It's applied initially with negative 9.8 meters per second squared, Earth gravity, and because I had the particles selected and then created gravity, those particles now have a Gravity Field 1 attribute tab. This Gravity Field 1 affects any object that is affected or linked to that gravity. You can link things in the Dynamics Relationship Editor if you need. What I can see in the gravity is that it has its own magnitude and attenuation, in this case going infinitely down on the y-axis, and can have distance and volume control, choosing a shape if we need and a certain position for that shape. Fields have their own transforms and their own custom attributes for their behavior. Now with these objects linked, I'll play and I can see the spheres are streaming out, bouncing down, and hitting the plane and arcing over. This is made possible by a gravity field, which is causing those spheres to fall gracefully, given their mass. Other fields include air fields to simulate wind, turbulence for adding noise to an otherwise too uniform simulation, vortices, or a single vortex, to be able to make tornadoes or small whirlwinds. We can add fields and any number of them to any simulation. As long as objects are connected to them, they'll show up in those behaviors. And it's important to recognize that each field generates its own tab in the attribute editor for the affected object, and that each field has its own particular set of attributes in addition to its own transform. Organization in a scene is crucial, especially when you get into large scenes. This bridge, as complex as it looks, is actually a fairly small scene and is missing most of the rest of the buildings behind it and also the fluid sim for the water. We need to keep careful track of the names of our objects, and we have some great tools to be able to do it with. I'll choose Modify and Search and Replace Names. In the Search and Replace dialog, I can search for a whole name or even a piece of one and replace it with something else. For example, I'm going to select one of my pylons, and this one is named Pylon 18. I'm going to search here for pylon, and I'm going to replace it with, we'll call this Big Pylon. I'll go by the selected objects, and I'll replace one. If I replace from the hierarchy and click Replace, it says I replaced two names. Depending on what's available here and how things are parented or otherwise organized, we may see more replacements in there. This is still named Pylon, which means that although in the hierarchy another one replaced, not all of them did. I'll go back here to Modify and Search and Replace Names again, and replace Pylon with Big Pylon in All. When I hit Replace, I can see I've replaced 54 names. It's actually taken all of my pylons in here, and they've all been renamed Big Pylon. What this lets us do is make things as fast as we can think about it, and then come in and organize later. We can also add a prefix if we need, again choosing Modify and Prefix Hierarchy Names in this case. To any selected objects, we can add a prefix of something we'd like. Maybe a two-letter code that identifies a direction or placement, for example. It's important to stay organized, and typically we organize our scenes by name, by color, by display and render layers, and also by selection sets or anything similar. This way, we can get in and find what we need, or apply materials on a mass scale. Organization is also the key to good lighting, so we need to be able to get in and rename things as easily as we can. For exporting files or data to other applications, FBX is the format of choice. Here's why. I'll select one of my pylons and choose File and Export Selection. I'll export this out as an FBX, and we can see here in this dialog that it will include all kinds of data. We can take across geometry, including our smoothing groups or hard and soft edges, smooth meshes. We can take animation. We can even bake this and resample it if we need. We'll take across bones, skins, and blend shapes, and our curve filters, defining or redefining curves as needed so that they come across to other graph editors and other applications seamlessly. We can take over cameras, lights, and other media. If we're allowed, we can embed media such as textures, and this again depends on where we're going. We can even set units as we need. For example, we might be going out to a game engine who needs a certain unit conversion to work correctly. We also have a choice of what axis is up and what UI we're using. Finally, there's a versioning, using FBX versions from 2014 all the way down. FBX is vital because it takes across models, UVs, smoothing groups, animation, rigs, skins, cameras, and lights. So for transferring to other applications where we need those things, the choice is in FBX. In Maya, scripting lets you extend both the functionality of Maya and rig together different objects to share disparate properties or react to each other in a very custom way. I'll add an expression into my gears here, showing a very simple expression and some of the power we have in it. I'd like to make P-cylinder 1 depend on the motion of P-cylinder 3. I'd also like to have cylinder 2 depend on cylinder 1. I'll open up my expression editor, either by right-clicking on a particular attribute I'd like to put an expression on, or choosing Window, Animation Editor's Expression Editor. First, here in the Attribute Editor, I can right-click on the Rotate Z of P-cylinder 2. I'll choose Create New Expression. I'm going to take P-cylinder 2 and make it equal something. I'll put in, having copied and pasted, P-cylinder 1. Now these gears are different sized. The small gear is half the radius of the bigger one. So I'm going to put in here times 0.5 to slow down that motion. And I'll put a negative in front. The big deal with expressions that makes them different from constraints is that expressions can relate unequal properties or include multipliers, for instance, like 0.5 to make half the rotation. We can also use them to flip the direction of that rotation. In this case, the negative in front of P-cylinder 1 is rotating it counter to P-cylinder 2. I'll add a semicolon in to end the line and name this expression, calling it gears. I'll hit Create and then Close. Now when I select P-cylinder 1 and rotate it on the Z-axis, P-cylinder 2 rotates half the speed. One of the other things with expressions is that it's easy to get in and edit. Instead of being times 0.5, it should have been times 2. I'll edit this by choosing Window, Animation Editors, and Expression Editor. In here, I'll right-click and sort my expressions by expression name. And there's my gears, and I'll change this over to 2. I'll hit Edit and update that expression. Now my gears are meshing together. It may need a little work in the initial rotation, but the idea of one gear dependent on the other via a script is very important. I can do the same with this one, simply making it a negative of the rotation of P-cylinder 1. All of what we do in Maya is actually recorded as a script if we need. We can choose Window, General Editors, and Script Editor. In our Script Editor, we can see all the commands that we've done. And we can also record things like tool switchings by choosing History and Echo all commands. This allows us to see even viewport switchings, such as Panels, Perspective, Perspective. This whole stack of code shows me that I'm navigating through that menu and choosing that perspective camera to look through. Either way, whether we do it in the expression editor or putting a script into the script editor, we can see that scripting adds on a tremendous amount of customization and flexibility in our workflow. allowing us to repeat a sequence of commands, for example, or make objects dependent on disparate properties or attributes in other objects. When we're working in Maya, it's important that we understand where objects think they are and how big they think they are. We can accomplish this easily by selecting an object and looking at its transforms, either in the channel box or the attribute editor. In this case, I've got a series of vaults here, and we can see that they've been scaled down to 0.944. This particular section thinks that it is 835.344 units out. When we're dealing in things like dynamics, for example, or light, we need to make sure that objects think they are the size that they actually are. If I'd like to zero this out, I can select one or more objects and choose Modify and Freeze Transformations. Freeze Transformations zeroes out Translate and Rotate and makes scale 1. So now this object is localized at its own 0, 0 and thinks it is the size or scale that it actually is. Instead of being maybe a different size with an offset pivot or thinking that it is somewhere else, now this actually is where it thinks it is. This differs from resetting the transforms. If I select another vault, for example, and choose Modify, Reset Transformations, this vault will jump over to 0, 0 with a scale of 1 and a rotation of 0. The difference here is that this is now positioned at 0, 0, 0 in the world, and the scale is reset to 1. However, as you can see, that vault section jumped away from the other ones, upsetting the model. I'll undo this and freeze those transformations instead. Freezing the transformations then zeroes out Translate and Rotate, resets scale to 1, but leaves the object where it is. This is especially important in rigging, where we want objects to be reset once they're modeled, so they start at 0 for rotation, for example. It's also important to understand how to get around your scene. We can choose Window and Outliner, and the outliner gives us a list of all the things in our scene. For example, I can see all of my cameras are listed, and they're deep gray, which means they're hidden. There's a Polysurface 1 node, and some transforms left over, it looks like, from a mirrored cut mesh. Polysurface 2 then is a transform that's left over. And down underneath all the meshes is a turtle default bake layer for the turtle renderer, a default light set, and a default object set. We can sort this outliner either alphabetically or by scene hierarchy by right-clicking and choosing Sort Order. Additionally, we can look at different attributes in here, showing connected information, just shape objects for example, attributes we'd like to see, and so on. It's a powerful way to navigate around the scene, select pieces that we need, and grab a whole bunch of objects for tasks like renaming or assigning materials, for example. We can also see what's going on in our scene by choosing Display, Heads-Up Display, and Object Details, for example. When I select an object then, the object details show me distance from the camera, if back faces are on or off, and smoothness. It also shows how many objects I have selected. Choosing Display, Heads-Up Display, and Poly Count gives me a poly count for both selected objects and my total scene. In games, for example, it's very important to manage the poly count, striving to be as low poly as possible while maintaining the silhouette and curve of the object. For compositing, we may need distance from camera to set up render passes, for example. We may also want to be able to pick things in a complex scene and understand their relationship to each other, how far they are away, and what layer they're on. Being able to manage your data and reset where objects think they are and the size they are is very important because it affects many, many different parts of our production pipeline. Thanks for watching the Autodesk Maya Certification Exam Preparation. Make sure you look over the roadmap, study the software, and look into each of the objectives that's on that exam. And I'll see you at Autodesk University.